Hello, welcome back to College Algebra. This is section 6.6. If you haven't already viewed my 6.4, which we talked about the definition of logs, please do so. And if you haven't looked at 6.5, where we talked about the properties of logs, please go back and look at section 6.4 and 6.5 before viewing this video, because I'm going to assume that you have the definition and the log properties. Those are going to be necessary in order for us to solve or to undo exponential functions. So your first example for solving is the lesson that the log of this is equal to the log of that when this equals that. Let me show you what I mean. Here's the log of this, which I would pronounce this the log of 4 base 3. And as long as the bases are the same, we're not going to have to worry here. This is going to be nice. One of the third properties, this is what I was talking about, go back to section 6.5, says you can, it's the power property, you can throw this 2 back up top. So you can dump it down out front, you throw it back up top. And this is what I mean by the log of this is equal to the log of that. The log of this is in yellow, the log of that is in blue. The only way for the log base 3 of this to be equal to the log base 3 of that is if this is equal to that. So 4 has got to be equal to x squared. That's the only way that the equation would be balanced. So x is equal to plus or minus 2 here. Now this causes a little bit of questioning, because remember, you need to go back to section 6.4 where we talked about the definition of logs. And we graphed logs as well. All log functions go through 1, 0, unless I'm taking the log of a negative x. But notice that you cannot take the log of a negative number. Now, you can graph the log of negative x, but then your values would all have to be negative, because this would be the log of the opposite of negative 2. So the log of the opposite of negative 2 is the same thing as taking the log of 2, which you can do. My point is, you can't take the log of a negative. The graph might exist over there. Go look at section 6.4. So when I'm saying that x is equal to 2 or x is equal to negative 2, my question is, does either 2 or negative 2 cause me to take the log of a negative? And right here, Houston, we have a problem. I can't let x be negative 2. So my final solution is 2, and negative 2 is called an extraneous solution. You can either throw it out or put it in parentheses or denote. That actually doesn't check. If you were to graph these on your graphing calculators, it would only cross at 1 point. Remember, careful when you graph this, because you've got to get base 3 in there, which in order to graph this, you would have to type in the log of 4 divided by the log of 3. That's that change of base rule. Notice that I'm changing it to base 10, and then that allows me to graph these functions. So you could actually set this graph equal to this graph and see that it does cross at x equals 2. For this one, we're going to use the product property, which says the log of a plus the log of b is the log of, here comes a times b. Notice that the log properties say you just drag the base along, so I hardly even worry about the base at all. I'm going to multiply this together by doing the FOIL method. So let's see. Well, I'll do it in the order that it's given. I was going to reorganize this, but it's okay. So my first term is just x. My outer is negative x squared. The inner is a 2. And the last is negative 2x, which I think I can combine some stuff. So this is negative x squared minus x plus 2. Now, how do we undo addition? Subtraction. How do you undo multiplication? Division. How do you undo this log? Change it into an exponent by doing this fishhook definition, which says 2 to the first is equal to negative x squared minus x plus 2. The next thing I would do is subtract off 2 from both sides. That's pretty nice. So now I just get 0 is equal to negative x squared minus x. Let's throw everything on the other side so I can have a positive x squared term. And factor out an x, leaving me with x plus 1. And it looks like I've got 2 solutions, either x equals 0 or x equals negative 1. Now remember, I didn't say throw out negative answers. I said throw out answers that cause me to take the log of a negative. So I need to check, does that negative 1 cause problems? Well, yeah, right here, because remember, you can't even take the log of 0. The log of 0 is also undefined because we have an asymptote at x equals 0 for log functions. So yeah, I have to throw out the negative, not because the negative 1, not because it's negative, but because it causes me to take the log of a negative, or in this case, the log of 0. So again, the only solution here, well, let's see, does that 0 work? Yeah, 0 is going to be fine. So this is the log of 2, this is the log of 1, which is 0, but that's okay, it's okay, it's okay. I can take the log of 1 and get an answer. It just happens to be 0. That's different than taking the log of 0 and getting an undefined answer. This one, to solve for an exponent, to undo addition, we do subtraction. To undo multiplication, we do division. To undo this exponent, I'm going to log both sides. Now be careful. If it said x cubed is equal to 7, I would not log both sides. I would simply raise both sides to the 1/3 power. That's how you undo exponents as well. But if it's a variable exponent, then I can't take the x root. There's no such thing as the x root of something. So I can't do this. So what do? We come up with a log definition. I can do anything I want as long as I do it to both sides, and I'm going to choose to log both sides. Once I've done so, I can bring that x down out front. And last step is to divide by the log of 3. Remember, this is going to be base 10 because I haven't written the log. So you can actually type that into the calculator and get a decimal equivalence. And then you could go back and check it. 3 carried up, whatever that decimal is, and check to see if it actually does equal 7. Remember, you're going to round that decimal, so it's got to be close to 7, not exactly. The important thing is to isolate this exponential function before you begin. So the first step here is probably to divide by 5. Our next step is to undo an exponent. I'm going to log both sides. Here's another way to do this, which some professors teach, and which is changing your exponents into logs by using the definition backwards. I found students aren't so hot with that. They're good with b to the y equals x, but if I give you b to the y equals x, it's very hard, I found, for students to go back to the log of x equals y, base b. You could do it. I'll show that to you in just a moment. But it's easier, I think, if you think about just logging both sides, bring the x down up front, and then the last step is to divide. Now, be careful here. Some of you know some log properties, and you might think that this is the same thing as the log of 3/5 divided by 2, and that's simply not true. So you actually have to type in the log of 3/5 and then divide that by the log of 2. That's actually equal to the log of 3/5 base 2. So my final answer could have been this, because this is equivalent to this. It's just not equivalent to this in pink is different. This in pink is actually the second property, which says the log of 3/5 minus the log of 2. Don't get that confused with, this is called the change of base property, and students get that mixed up with the second property, so be careful. Here was that definition. So again, go back and check out those videos. I could do if 2 was equal to 2, this would be an easy problem. I'm just set the exponents equal to each other, but because they're not, I'm going to log both sides to undo the exponents. So what does that mean? Undo it. I'm going to dump them out front. So x minus 1, that's the third property, equals 2x plus 3 times the log of 5. Now, to solve for x, my suggestion would be get all the x's on the same side and factor on an x. So I'm going to see. Wow, that's a tough problem. I'm going to actually distribute these things, I believe. There might be an easier way, but I'm not seeing it right now. So x log 2 minus log 2 is equal to 2x log 5 plus 3 log 5. Jeez. So I'm going to try to get these x's. I hope I'm doing this the easiest way. I'm going to try to throw these x's on the same side. So x log 2 minus 2x log 5 is equal to 3 log 5. I'll add this to both sides, plus log 2. This is just some creepy decimal, which my calculator will do. If I factor out an x on this side, I'm left with the log of 2 minus 2 log 5 is equal to, well, let's call this decimal 1. So at this point in time, I'd probably just type that in. Remember, don't round until the very end. And let's call this decimal 2, because that's just some creepy decimal 2. So I'll just divide by decimal 2. Divide by decimal 2. And this will cancel. So my final answer is whatever this creepy decimal is divided by this creepy decimal 2. I hope I did that right. we'll end up with a third creepy decimal 3. But important, don't round these things until the very end. You can only round once here in math. This is interesting because these are called sometimes U substitutions. So there's a hint over here. If you replace 9 to the x with 3 to the x squared, then we can try to factor it. But if it doesn't factor, we can use the quadratic formula. So again, as I mentioned before, sometimes they're called U substitutions. You look at this middle term, and we're going to let u equal 3 to the x. Then if I square both sides, I'll get 3 to the x, the whole thing squared, which is really equal to 3 to the 2x, which is the same thing as 9 to the x. So this is my u squared term. So I'm going to let u squared be that 9 to the x. This is minus u, because I did my u is 3 to the x, minus 6. So then I try to look for factors of 6 that differ by 1. Hey, I don't have to do the quadratic formula. Why can't I choose 3 and 2? Oh, I hope I did this one right too. So u and u, signs are different, the larger is negative, plus, so either u equals 3 or u equals negative 2. But remember, I'm going to go back and change that u substitution to be 3 to the x equals 3, or 3 to the x is equal to negative 2. And then I'm going to solve for an exponent, we're going to log both sides. Can't divide by 3 here. To undo that exponent, log equals log 3. Dump that out front. X is equal to log 3. I've done something wrong, certainly. Well, I started doubting myself because this is going to be x equals 1. I actually typed it into the graphing calculator, 9 to the x minus 3 to the x, and I looked at it because I thought certainly I'm doing something wrong. But actually, when I graphed this thing, I can actually see it does go through 1. I can even hit trace 1, enter. I'm looking for those zeros, and sure enough, boom. That's a good solution right there. So x, I'm convinced, does actually equal 1. And I bet, according to my graph, this side should be extraneous, but let's finish this up. The log of 3 to the x is equal to the log, well, this is why it's extraneous. What's going to happen when you try to take the log of negative 2? You get an undefined value. So this yields no solutions over here. So the only solution set, as you could see from the graph, was 1. So again, there's some multiple choice. You can practice. I like this worksheet. If you're interested in this worksheet, you can email me and I will share. You make sure you get these answers. Here's some more problems. You can pause the video, try to work these out. Here are the answers. Here are some more problems. This is a great one because you have to actually use your calculator because this is not factorable. So you have to guess left, guess right, guess on to actually find the roots. Because you can't even use the quadratic formula because it's not even a quadratic function. So you can use your calculator on the next test, but make sure that you remember how to calculate roots. Here are some answers. This one is good. I'm going to define the log of 6 base x as something other than what your calculator will give you. Because if you can't type in the log of 6 base x because your calculator doesn't know what the x is. So if I define the log of 6 and I define the log of 10 and define the log of 2, how do you find the log of 180? Well, the goal is to try to use a 6, a 10, and a 2 to end up with 180. So let's see, 6 times 10 times 2 doesn't quite do it. That's 120. So let's try it again. The log of, I don't know, 6 squared times 10 times 2. I'm coming around with different things that could be a possibility. So I got to figure out what combinations of 6, and I remember I can square it because I have a power property. That would give me 180, and obviously 36 times, this is way too big. Now the other thing you could do is something like 6 squared times 10 divided by 2, because we have a quotient rule as well. So I think that might work. So again, expanding this is the log of 6 squared plus the log of 10, which is not a 1 because I defined the log. These are all base x, of course. And then I'm going to subtract off the log of 2. So then I just throw this out front. So 2 times this decimal plus that decimal minus that decimal, which I've defined all of these decimals for you. So you go back now and plug in the 0.56778. Good thing we can use our calculator because you don't want to do this by hand. And plug in this 1.2 34 here, and plug in the 0.3030 here, and number crunch it and see if you don't get this answer, 2.0666 repeating. There's another example. You can go through these examples and see if you get those answers. I like 15. I'll end the video with 15 because 15, 16, and 17, they're all very similar. They look similar, but I do something very different. This says the log of A minus the log of B, so I would divide. The log of A divided by B is the definition. And now I use the rule, the log of this is equal to the log of that, when this is equal to that. And I'm going to cross multiply and divide here to get 3x is equal to 2x plus 5, so x is equal to 5. Now, watch out. This one, notice I've got the word log over here. In number 16, I take out the word log. Otherwise, 15 and 16 are the exact same problem. So I'm still going to use the quotient property, the log of A minus the log of B is the log of A divided by B. But this time I can't just unlog like I did on the previous one. See, if both sides are being logged, I just drop the log. The log of this equal to the log of that when just this is equal to that. So I just drop the logs. Over here I can't drop a log, but I can undo the log. Remember, if I didn't write the base, we know that it's base 10, and now we can do the fishhook definition. 10 cubed is equal to 2x plus 5 divided by x. Well, that's 1,000. I'll multiply both sides by x and get 998. X is equal to 5, so x is not pretty, but I'll leave it, 998. But this one's a little bit different because I'm changing this minus into a plus. So instead of dividing, I'm going to multiply 2x plus 5 times x, that's the product, equals the log of 3. So the log of 2x squared plus 5x should equal the log of 3. And again, it's the log of this equals the log of that, so I can just drop the logs. You can do that as long as both sides have bases that are the same. In this case, base 10 is good. And now we're down to factoring. So we need to look for factors of 2 and 3 that differ by 5. So I think I'm going to use 6 and 1. So my outer terms are 6 and 1, differs by 5. Signs are going to be different. The larger term is positive, so I want to make the 6 positive. Of course, it needs to be negative. So my final solutions are x equals 1/2 and x equals -3. But every time I see a negative, it reminds me about extraneous solutions. And yes, you've got to throw out that -3. Sometimes we throw out positive answers too, because if it causes me to take the log of a negative, I've seen, you better check all positives and you better check all negatives. The final solution here is 1/2, whoops, and then the -3 is called an extraneous solution. Let's see how I wrote it over here. Yeah. But you better check it out. I've seen things like the original problem says the log of x minus 8 plus blah, 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 and then you end up with like x equals 2 for the answer. And even though 2 is positive, notice it's extraneous. So you can have positive extraneous answers too. And I've seen things where it's like 8 minus x, and you get x is equal to -4. And you think, oh, I have to throw that out. But no, -4 actually works in this time, in this scenario, whatever the problem was. So it's not because the answers are negative that you throw them out. It's because they cause you to take the log of a negative. So be careful with that. I've run a little bit long, but here are some remaining problems. If you'd like to work out again, if you want the worksheet, you can email me, and I'll see if I can get you the worksheet with some worked out solutions and answers, although they're all right here. But if you need a clean sheet, you can certainly email me. I hope this is helpful. Good luck on your test.